And now we're very excited to get a different perspective on autism. And what we're going to do now is hear from our panel. We have three amazing people who are going to highlight some of the innovative research taking place in the autism field. So this is an opportunity for us, most of us are probably not scientists and researchers in the room, to understand a little bit about what's going on in the academic community and the scientific community as they seek to determine the underlying causes of autism, methods of diagnoses, and successful interventions and resources. We're first going to hear from Mathew Pletcher, followed by Michelle Gorenstein-Holtzman, and then from Meryl Alper. And as each one of them comes up, they will introduce themselves and tell you a little bit about what they do. And then at the very end of the panel, once Meryl, who is our last presenter, is seated, we'll have time for questions and answers, so I will come around with a microphone. So please join me in welcoming our next panel.
Wow, you learn something new every day. I've been a lifelong baseball fan. I never heard that story about the Dodgers before. So now I've just got to find a way to slip it into conversation so I can sound smart. But anyway, so thank you so much for having me here today. I really appreciate the opportunity to talk about some of the work that we're doing within the science effort at Autism Speaks. And again, thank you for just what I think is a really important meeting to be had in the sector. So, since the very earliest days of Autism Speaks, the support of science and research into autism has been one of its main pillars. And that really comes from the appreciation that if we are going to achieve our overarching goals of improving outcomes for individuals with autism, we simply need to have a better understanding of the causes, of the underlying biology, of the available treatments and therapies, and really be able to push the envelope in that area of knowledge to really be able to enrich the entire ecosystem. And for that reason, it has been a cornerstone of our efforts since its founding. One of the biggest investments we've made in science recently is one of the efforts I'm going to talk most about today, and that's something we've called our Missing Project. And the name comes from the idea of trying to help fill that data gap, that missing data and information necessary to really speed new discovery in autism. And the form that this has taken is investing in whole genome sequencing, genetic decoding of autism. And so the initial goals of the project was to generate 10,000 whole genome sequences. So this is every letter of DNA in one cell, so the entire book of life, for 10,000 individuals with autism and their families. And then do that in collaboration with Sick Kids Hospital in Toronto and Verily, the life science arm of Google, to both really dig into that data, but also to make sure that that data is available to the largest community of individuals possible, both researchers and families themselves, to make sure that we're actually utilizing that data once it's generated for the greatest impact and the greatest effect. So where this project stands right now, at this point, we've completed sequencing of over 7,000 of those genomes. We have another 400, 500 that are currently on the way, and we have enough samples already lined up to hit that initial goal of 10,000. There's been numerous papers already published using the data. I'll talk about some of the findings of those papers in some of the upcoming slides. At this point, we have over 90 investigators from over 40 institutions in 9 different countries who have applied for and received access to the data set and are currently working with it. We've built out a web-based platform for them to be able to easily go in and browse and access the data. And then I think just as importantly, right now we're in the process of building what we call a community portal. And this goes to the fact that, again, as an organization that is meant to represent the families and the individuals with autism, that if we believe that there's value in this genetic data, in this DNA, and I think obviously do because of the investment we made, that the families who help make this effort possible should be able to actually benefit from not sometime in the indefinite future, but right now. And so what the portal's meant to do is be able to, so those people who have contributed samples can come in, see what's been found, be updated on the latest information that's being researched, be able to take that information, share it with their physician, and be able to connect with each other around the genetic information that's being discovered and identified. So in thinking about why to undertake a project like this, certainly one of the questions we typically ask is where, if we apply our resources, do we have the greatest likelihood of success? Where do we have the greatest likelihood of having a real beneficial, meaningful impact on the science and the understanding. And where can we really build on the work that's already come before us? And I think what that work that has come before has really highlighted is the importance of genetics in autism. And there's a number of clues and signatures of that, and just some of the studies that have been done before. And investigations of monozygotic twins, identical twins, individuals who share the same genome. What's been reported is that up to or even as high as 90% of the time, when one identical twin is diagnosed with autism, the other one is as well. So there's a really high concordance just based on that genetic similarity. Likewise, there's a high likelihood that a sibling of an individual diagnosed with autism will also go on to be diagnosed with autism. Some studies reporting the odds of that being as high as 1 in 5. So there are a number of these kind of things saying that, in fact, genetics are important, and so therefore, if we invest in this space, we can gain some of that needed understanding of the underlying biology. And even to that point, just in the last year or so, a couple of different studies from groups at Cold Spring Harbor here in New York, as well as University of California, San Francisco, have taken the available data and suggested that as much as 50% of cases of autism can be explained by rare mutations in genes. And so again, but to find that, we have to generate the data first. And that's what a lot of this effort is. It's about generating that data so we can begin to do that investigation, which leads us to the other important decision in investing in this, and that was to do whole genome exome, every bit of DNA. Sort of the way most research is done right now is a focus on what we call exomes, which are just the parts of the DNA that contains the genes, the parts that are expressed, turn into proteins, run the cell. And this is sort of a behavior that's typically called looking under the lamppost, where you focus just on the area that's most brightly shown on, that you kind of understand the best. But in doing that, you leave out a lot of important stuff that sort of sits out in the dark. And that's the case with our genome, too, because those exomes, those genes, only make up 2%, 1 to 2% of your DNA. And that other 98% has important clues in biology as well. And so to actually be able to get into that, you've got to generate the data first. And so that's why we want to do whole genome sequencing as well. So what did we hope to get out of this effort, and what are we seeing out of it? Well, certainly, again, just in the idea of understanding that underlying biology, that we expected that we will find new genes that relate to autism, that cause autism. And in fact, that's what we found. We just recently had a paper published that described the first 5,000 genomes. And in that, we found over 60 genes that could be very conclusively tied as a cause of autism. 18 of those we were describing for the first time ever as a cause of autism. And that's what the figure on the right there, on your left, is just a list of some of those genes we found. But I think just as importantly, especially in our goal of gaining sort of a bigger picture understanding of autism, is that often these genes collapse down into similar pathways in the sense that even though the genes are different, they kind of do related things within the body. And they tell us a bit about what that biology is. For instance, what's shown in this figure with all the little dots and circles are how some of these genes fit together in these networks, how they relate. And what we find is, not surprisingly, certainly some of these genes relate to things like neuronal function, how the neurons in our brain talk to each other, signal each other. And in fact, certainly that's not surprising that something like autism, genes like that are involved. In addition, there are genes that fit into a segment called sort of gene regulation. They tell other genes how to turn themselves off and on, when to turn themselves off and on. And so it's by understanding these larger picture things that we can again think about, well, what's the best way to approach autism from a medical scientific perspective? Another sort of goal, I think, of this project can be stated by some of the actual participants. And so just play a quick video here of one of the families that are actually taking part in missing. Oh, I guess can't hear the sound. Always happens when you show a video, right? It's surprising. It's okay. I can go on. But the point of the matter is what this family talks about is this sort of certainty that a genetic diagnosis gave them, a better understanding of what their experience and their child's experience, and certainly what that certainty means in things like obtaining or actually taking action and doing things. We earlier talked about how important it is for things like early intervention with children with autism. And some of the things is by making genetic tools, genetic diagnosis more readily available, we can help speed some of that diagnostic certainty, leading to earlier intervention and then better outcomes for those individuals. So I'm going to go ahead and move on. So, and then, but, whoops, gone too far. There we go. So, but I think sort of the loftier goal that we have for autism, for what this project is meant to do, I think aligns with some of the sentiments you've already heard today. And that's around, I think in some ways, it's really fundamentally changing the way we diagnose, talk about, think about, discuss, diagnose, treat autism. And that's breaking that single diagnosis apart. Again, it was said very early, you met one individual with autism, you met one individual with autism. It's so true. And the thing is that right now, we're left with this umbrella diagnostic term that groups together such a wide diversity of personal experience, medical needs, social needs, supports, that term in and of itself isn't particularly useful. And so one of the things we hope a data set like this can contribute to is us gaining a better understanding of the unique subtypes of autism, and then be able to better assign the appropriate and provide the better and more appropriate care and supports for those individuals based on their specific needs. And just to this point about how diverse autism is one of the findings out of the first paper that we published out of Missing was even within the same families, you often see different forms of autism. Here are two, what you call pedigrees, mom and dad on the top, in the one case, brother and sister, brother and brother. Many times when we look at families with multiple individuals diagnosed with autism, they have different genetic forms of autism. It's not the same autism even within that same family. So making that, then trying to carry around a generalization to the entire population that it's one thing just doesn't work, and I think the science helps support that and backs it up. This is an effort that was undertaken by a group at Harvard to try to begin to break autism apart, to think about it in different subtypes. And this type of effort, what they did is they actually took thousands upon thousands of clinical records and looked at all of the different medical history of individuals diagnosed with autism and said, are there different subtypes just based on how individuals present in the clinic? And what they found is they could define 4 different groups. Some of them were characterized by the presence of seizures, some were characterized by developmental time points. And information like this, subtyping like this is useful because it does say if someone is able to receive a bit more information about their autism like this, what kind of particular issues they're most likely to see, and even more so, at what ages are you most likely to have that particular issue so you can get potentially the right kind of treatment at the right time. But of course, a problem with a diagnostic criteria based on a clinical presentation is the person has to outwardly manifest, outwardly demonstrate that issue before they can be assigned to it. And I think that's where, again, genetics can potentially help us get ahead of that a bit. And again, the importance of why this is important is just, coming straight from a study like this from a year ago, where again, this has been shown again and again that individuals with autism have a shorter expected life expectancy. And the conclusion here is premature mortality was markedly increased in individuals with autism owing to a multitude of medical conditions, meaning again that we're just not providing the right care at the right times to individuals, and it's not matching their needs to be able to get the best outcome for each and every individual. And so what we're starting to see as we appreciate and start to dig into the genetics is a better basis for able to assigning matching care to needs. This is just one particular example, a discovery of an autism gene, CHD8, made about a year and a half ago. And in fact, now it's being recognized as one of the more common genetic forms of autism. But as they gathered together individuals who had mutations in this particular gene, they found, in fact, yes, there is a commonality of life path here. There's a commonality of medical needs around that. In fact, individuals with this particular mutation have a higher likelihood of developing schizophrenia or a higher risk for seizure disorders. That, in fact, now having that information helps direct family, individuals, doctors in thinking about what is the most appropriate care for that individual. And again, I think just as important is that at the same time, this is helping connect families again. The idea that now, whenever an individual family receives a new diagnosis, and you look to the community to help fill in the gaps, help gain an understanding of what's in front of you, what's needed, well, you're much more likely to have an informed answer back to that question, knowing that you're talking to individuals, families who are going to have a similar or already had a similar experience because of that common genetic diagnosis. Just another example of this is work that's been done around another genetic form of autism, this caused by a duplication, an extra copy of a bit of chromosome 15, also called DUP15Q. And again, once this group of individuals identified a clinical consortium built around this, specializing in the care of this particular set of individuals with this specific type of autism, really focused on, well, what does it mean to have DUP15Q autism, and what can we do specifically to meet the needs? And again, one of the recognitions was individuals with this specific change in their genetics were more prone to seizures. So now, it's been recommended by this consortium that when an individual receives this genetic diagnosis, one of the first things they do is undergo a 24-hour EEG evaluation to really be able to look and assess whether or not that child is going to be prone to seizures before even the first seizure arrives. Because again, one of the things we recognize that a lot of times these seizures could be incredibly damaging, can have lifelong effects. So you want to be able to get ahead of this, to be able to apply care before that first seizure. And now, with this understanding, it becomes possible to take that sort of prophylactic type step. And just a final little story here before the last slide is another bit of information that came out of the Missing Project and some of the work we've done. And this was the discovery of a new gene that was found in a number of individuals with autism. It's a mutation in a gene called period. Period is one of the genes that actually are part of our internal clock mechanism. The thing that tells us, when you should be waking up, when you should be going to sleep, when you're hungry, when you're not, those internal cycles you go through on a daily basis. Well, that's run by these genes that turn off and on regular basis within your body. It's also well appreciated that individuals with autism, a lot of them have significant issues with sleep. And there's a really strong interplay between issues with sleep and behavioral social issues. Again, you can think about just in your own life what it means to not be able to get regular sleep and how that impacts how you interact with others, with your family, and what kind of profound effect that could have. So for these individuals, what this could be telling us is, in fact, if we were to take an approach that focused specifically on the sleep disturbances, that could be actually of greatest impact and greatest benefit for them, because that links directly to the underlying driver of that specific form of autism. And then just my final note here too is that stepping beyond that and thinking about how this kind of information even begins to empower us, thinking about new treatment, new ways of being able to, novel treatments. Something that's been thought of for a long time as a potential benefit in autism is the use of oxytocin. It's sort of called the social hormone. But there's been the results for these kind of studies with oxytocin have been highly variable. They've never been able to see a really positive, true signal to say that this is going to be useful. But just recently, a group in Japan did an investigation where they found that, in fact, changes in the oxytocin receptor, the part of the protein that's actually responsible for collecting oxytocin and making the cell respond to it, that predicts whether a person responds or not. So again, there actually may be a subset of individuals who could receive great benefit from it. But because we haven't been good at identifying who those individuals are, we lose the signal for the noise. We lose that positive signal, and again, these kind of treatments fall to the wayside when in fact they could be beneficial for some. And so with this kind of understanding, with being able to begin to understand and appreciate autism very much on an individual basis, or at least on a subtyping basis, I think holds a lot of promise in thinking about how we go forward, how we proceed in being able to provide the best care and treatment for all individuals. And so I'm going to stop there and I guess hand it off to our next speaker. Thank you.
Well, thank you for that wonderful talk. And I feel like a lot of what we do at the Seaver Center is going to kind of talk about what we're doing to solve some of those problems that you just brought up. So thank you for that. So my name is Michelle Gorenstein, and I am a clinical psychologist and director of outreach for the Seaver Autism Center at Mount Sinai. My job is a little unique there. So most of my colleagues are researchers, and I'm going to be presenting their work today.
However, I'm actually not so much a researcher, I'm more of a clinician, and I spend most of my time in the community, talking to families, running social skills groups. So I'm going to end my talk about what I do, but today I have the very difficult job of presenting what all of my wonderful colleagues are doing at the center. So the Seaver Autism Center has kind of 4 pillars. Our research program, which I'm going to talk a lot about today, but I didn't want to kind of neglect our other programs, so I'm going to just briefly mention them. We do have an assessment and clinical program. We see patients privately for evaluations, treatment. We have a tremendous outreach program, so we do a lot of parent training at local schools, community agencies. We have partnerships with Synergia, YAI. We also do a lot with cultural institutions. In terms of, we helped create the Discovery Squad at the American Museum of Natural History, and a lot of the work that I do. And we also have a very large training program where we really focus on training medical students, psychologists, to work, even if they don't choose to have a full-time career, working with individuals on the autism spectrum disorder, to at least kind of get them to be knowledgeable and kind of give them some training. So we have a lot of medical students and residents coming through our center on a regular basis. But for the focus of today's talk, I'm really going to be focusing on our research program. So the Seaver Autism Center leads the field in kind of 2 areas, what I call preclinical research. So this is looking at etiological discovery, gene discovery, causes of autism, model systems. So our center does a lot with mouse and rat models of autism. We also do a lot in clinical research. We have a large group right now focusing on biomarker discovery, and I'm going to talk a lot about that. We have people working on novel interventions, one of them being Oxytocin, and my focus is on social skills. So in terms of the preclinical, and I'm so appreciative that you are here because I'm presenting the work of Dr. Joseph Buxbaum, who is the director of the Seaver Autism Center, and he is a geneticist, and this is something I can talk very briefly about, but definitely not an expert on. So the Seaver Autism Center is part of the Autism Sequencing Consortium, and similar to the Missing Project, the idea being to get a lot of scientists together that are doing this work, sharing data, so that way we can make discoveries more quickly and be working with a much larger data set. So right now there's 4 international groups and 150 researchers that are part of the Autism Sequencing Consortium. We have samples from about 29,000 individuals so far, and we've identified 75 autism-related genes to date, and that number's increasing. And we recently received $7 million, not Seaver Autism Center personally, but the Autism Sequencing Consortium received $7 million grant from NIMH to expand to about over 50,000 samples over the next few years. And these are just some papers that have come out of that, but again, when you put a lot of researchers working together, sharing data, and a much larger data set than any individual researcher can have, you have a lot more meaningful discoveries at a lot quicker pace. And I think this is definitely the way the field is moving, because a lot of people are realizing the need to share data rather than just saying, this is my data and I'm going to keep it and I want to be the first author on the paper. So there's definitely a good movement there. This is the work of an epidemiologist at our center, Avian Reichenberg. He is part of the multi-generational familial and environmental risk for autism, the Minerva project. This project is comprised of 7 countries, one of them being the United States and California, but Sweden, Israel, and it's a multi-generational study of environmental risk factors in over 62,000 cases out of a population of 27 million. And the idea being, again, that if you put a lot of data together from a lot of countries, you can have more meaningful results. So this study is looking at pregnancy-related factors, prenatal medication, some of the SSRI data has come out of this, the paternal age. This is also looking at grandparents' age. So the idea being that putting all this data leads us to kind of a position where we can have a large impact on public health. So this is kind of the real model for our center, and it's been borrowed a lot from kind of like the cancer research. So you have a disease, you try to discover the genes that are causing that disease, you create model systems, whether they're mouse, rat, monkey models of that disease. You try to replicate some of the behaviors, especially for autism, in the animal models. You try to understand the pathophysiology of the disease, so how is the brain working, how are the synapses talking to each other in the brain. You try to create a drug once you kind of have this understanding. You try the drug in the animal models. If there's improvement, then you bring it to people and you have novel therapeutics. So that is kind of what our center is trying to do all around. And we've been doing that, especially with one drug called IGF-1, which is a growth hormone. So Alex Sullivan, who's a psychiatrist I work with, this is his work. And IGF-1, we created a mouse model with a genetic condition called Phelan-Mcdermid syndrome. Phelan-Mcdermid syndrome, kind of similar to the conditions that you heard about previously, is a genetic condition that we know is highly associated with autism. It's also associated with intellectual disability, epilepsy, and other medical comorbidities. But we figured out, to go back, the disease, we found the genes, we created model systems, we tried to understand the pathophysiology, and then we created a drug treatment. And we looked at IGF-1 first in the mouse, and we saw that it improved kind of brain cell plasticity, so the ability to learn, and motor deficits in a mouse. And then we had a clinical trial with children with Phelan-Mcdermid syndrome, and we also saw positive gains in kind of social withdrawal behavior and restrictive behavior. We also look at biomarkers. I'm going to talk a little bit more about what I mean by biomarkers, but we're able to use the same kind of strategies to look at brain functioning in mice and humans through visual EEGs. So putting little electrodes and having individuals watch something on a TV and looking at how their brain processes that information. And we were able to see that in PMS, which is Phelan-Mcdermid syndrome, the mouse model with PMS and the child with PMS showed similar brain activity. So we know that we are creating kind of an appropriate mouse model, and that allows us to kind of do treatments and try things that obviously you wouldn't want to try on a human being first. So that was the preclinical research, and now kind of the clinical research. So in terms of our clinical program, every child that walks into our center kind of receives kind of this gold standard battery. And this allows us to kind of really figure out kind of what maybe subtype of autism they had, get a better sense of kind of their overall functioning. So everyone that comes into our center receives a thorough psychiatric evaluation. Every child gets the ADOS and the ADI, cognitive testing, and at this point we're doing 9 different tests depending on a child's age, language level. We do adaptive functioning using the Violent Adaptive Behavior Scale. We've created a sensory tool, so we do that on all the kids that come in, and we include some parent report measures. And then depending on what study a family is coming in for, they might have kind of different tests. So most of our families do genetics. They might have electrophysiology, like the EEGs or VEPs. They might do imaging, like fMRIs, eye tracking. So biomarker discovery at Seaver. And this is definitely the way that a lot of research centers are focusing on. So the use of biomarkers allows us to kind of understand better and individualize treatment. And biomarkers are kind of used to figure out how people are processing information, what's going on in the brain. And we use EEGs to do that. So we attach, for those that have had this, you attach a few electrodes. It's not invasive. Most kids are able to tolerate it. You have them look at different visual stimuli, and it kind of measures kind of some brain activity. And we do visual evoked potentials, and now we actually just have somebody from Yale who joined our faculty who's doing auditory potentials, so presenting auditory information to a child, and then kind of watching kind of their brain activity. We also do neuroimaging, so looking at brain structure, functional fMRIs, diffusion, tensor imaging, and eye tracking. And we also created something called the Sensory Assessment for Neurodevelopmental Disorders, which is kind of an objective measure to look at sensory processing. Now that the DSM-5 is out, we can actually look at sensory issues because we've always known it's there, but there's been very little research to date on sensory issues for children on the spectrum. So now we're able to look at whether children are hyposensitive, hypersensitive. Does that differ to sound, touch, visual processing, just to kind of help us kind of figure out each child individually. And why are we spending so much time on biomarkers and trying to figure out kind of what does your child look like? How is your child processing visual information? How is your child processing auditory information? How do they process sensory information? Because what we know, and kind of what you just heard about, is that we know autism spectrum disorders are very diverse. And what's happened in a lot of these clinical trials is we've gotten little to no treatment effects, and then there's no follow-up. But what researchers are figuring out more and more is that what's happening is we're trying to kind of throw one drug at a lot of different problems, and we're saying, well, why is it not working? Because you would never expect one drug to target a lot of different problems. So we're trying to figure out of this group of individuals who have autism, there might be some individuals that have side effects, but the drug is beneficial. There might be some individuals who do not have side effects, but the drug is not beneficial. And there might be some people who have no side effects, but it's not beneficial. And you might have some people where it's beneficial and there are no side effects. So obviously, if we can figure out beforehand that you're in this group, that's great. And then we could say, okay, we have a medicine for you to target some of your symptoms. And obviously, if we know that you're going to have side effects and it's not going to be beneficial for you, we'd be able to say, then this is not the drug treatment that you should be doing. So we want to find a biomarker, and what our center and Yale and a lot of other research centers are working on are finding biomarkers that predict response. So we want to test before you treat. And this has been the model in cancer treatment for a while now, and we're moving it more towards autism spectrum disorders. So biomarkers allow us to identify subtypes of autism, looking at how we process information and sensory issues. It informs personalized treatment approaches. We can monitor treatment responses. So sometimes what we're seeing in our work is that we might see, with a clinical trial, we might see a change in a biomarker or how a child is processing information and how their brain is working before we might see a behavioral change. And it identifies association between neuroimaging, so brain, and other biomarkers and clinical outcomes. Because obviously, if we're only seeing changes in the brain, but the parent is still saying the child is exhibiting the same problem behaviors or the symptom that we're trying to target, that's not helpful as well. So I'm not going to go through these here, but these are all of our ongoing clinical studies. So we have a variety of studies looking at biomarkers, sensory processing, genetics, brain imaging. We have one on improving access to care for minority youth with ASD, using a family peer advocate model, and that's in collaboration with YAI. My work, which I'm going to talk about, which is an employment-focused social skills group. We're part of the Autism Sisters Project through the Autism Science Foundation, which is focusing on genotyping lot of families using kind of just saliva, and the goal is to eventually look for a protective factor in females, just because we do know autism affects males at a much higher rate than females. We have studies looking at Phelan-Mcdermid syndrome, looking at the life course of Phelan-Mcdermid syndrome, so especially now that we've identified a lot of kids with Phelan-Mcdermid, tracking them throughout their lifespan. Just because a lot of kids with Phelan-Mcdermid do show a regression, so we want to be able to track it and have a better sense. So that way, when a child does get diagnosed, we could say, okay, here's what you might expect, and here are things to look for. We also have ongoing therapeutic trials, really focusing around IGF-1. So both with kids with Phelan-Mcdermid, and now we're doing it with kind of larger idiopathic autism sample, and oxytocin. So my area of interest is social skills. So I'm going to present the work a little bit of Dr. Wang and Dr. Soria, and the study was actually funded through Autism Speaks, and it was looking at fMRI and social skills. So it was a unique study in that it compared active social skills treatment based on cognitive behavioral therapy and a play-based social skills treatment. And what was unique is we were also doing brain imaging for the children pre and post to see if there was any changes structurally or within the brain. So we compared the CBT approach, which was the Seaver NET, which stood for Nonverbal Communication, Emotion Recognition, and Theory of Mind Training. And it was a teacher-directed instruction. We used a token economy, visual schedules, lots of structure. We broke steps down into concrete pieces. There was a lot of visual supports. To a comparison condition, which was an eclectic approach, using play therapy, leisure activities. We felt like what might be represented in a recreational program for children on the spectrum. It was a 12-session group, so both groups received 12 sessions of treatment. The results were published in JCAP in 2014, and what we did find is those in the Seaver net showed increased functioning in the medial prefrontal cortex and the temporal parietal junction, and these are two areas in the brain that have been associated with social skills, theory of mind, executive functioning. And we also saw that kids who had better social skills at the beginning also showed increases in this. So we know somehow these areas of the brain are impacting social skills. We also saw that those children that completed the Seaver net showed improvements on social behavior measures, although at the 3-month follow-up, unfortunately, the results were not significant. And those children that were in the Seaver net that had higher verbal IQs and that were older showed greater improvement. So again, at our center, we're always trying to figure out who are the responders, so that way we can better understand kind of what treatments work for which children. And at our center, we really focus on not keeping what we're doing in the ivory towers, because if the researchers are only keeping what they're doing in their labs, it's not really meaningful. So with these findings, we went to UJA Federation of New York, and they gave us funding to help disseminate our curriculum to community agencies. So at this point in time, I'm consulting on 10 groups across 5 sites. This allows me to reach 100 children each year that probably would not be coming to the Seaver Center. So I'm in Westchester, I'm in Brooklyn, I'm in Queens, and at WJCS we've developed a social skills group for children ages 4 to 5, really focusing on Connie Kasari's work in play. So again, taking what's being done in labs and in the research world to help community centers do more evidence-based treatments. And at WJCS and at the Manhattan JCC, I also developed a social skills group for teens. And kind of with our keynote speaker, we've heard there's really a lack of services for young adults on the spectrum. So I then created last year a curriculum. It's a 15-session structured group based on CBT. We actually didn't even test this in the research center. We brought it directly into the community, and we're studying it there. The topics covered are active listening, nonverbal communication, problem solving and teamwork, coping skills, theory of mind, making good impression, conversation skills, interview skills, and disclosure. The group is not meant to be an employment group. It's meant to supplement already existing employment programs like through Access VR or other programs, because from my work and talking to a lot of young adults, they were getting trained to do the job. But a lot of these programs weren't really focusing on the soft skills that are getting a lot of these individuals fired from their jobs. So I created a curriculum, and we're doing research on it right now. So we're using a randomized waitlist control design. So everyone who comes who has an autism diagnosis gets randomized into either a waitlist group or an active treatment group. And then those on the waitlist group get treatment, so everybody's getting the treatment. We did one cohort where we had 11 young adults on the spectrum. We are currently doing our second cohort. And we're examining the impact on the jobs curriculum on job-based social skills knowledge. So we're teaching these skills. Are individuals learning these skills in a meaningful way? Are they showing improvement on theory of mind and emotion recognition? Are they showing improvement on social skills? And are they showing improvement on quality of life and self-esteem? And we're measuring all of these before and after treatment. And then for some of those that get the active treatment right away, we're following them 6 months later and saying, do you have a job? Have you been on any internships? Have you been on any interviews? Did you find the curriculum helpful? And I will say again, this is not meaningful data, but just to give you anecdotal data. So for cohort 1, we had 6 individuals in the active treatment and 5 individuals in the waitlist control. And we just got the 6-month data back. 4 out of the 6 individuals are currently employed. And again, I'm not saying that's all because of the jobs curriculum. They were also in employment programs through the JCC. But 6 out of 6 said they thought the curriculum was very helpful. So I think more programs like this are needed, and hopefully when we get data, we can expand this program to agencies outside of just UGA Federation and kind of see if it works in other settings. So a lot of what I presented is the work of my incredible team, which is pictured there. Thank you. And now for something completely different, because I am a social scientist. My name is Meryl Alper. I am an assistant professor of communication studies at Northeastern University. I'm also a faculty associate with the Berkman Klein Center for Internet and Society at Harvard University. I'm also on Twitter at Meryl Alper. And I wanted to piggyback off something that was said kind of originally about people on the autism spectrum having been part of the origins of this museum, from the get-go. And also wanted to think about the ways that autistic folks have been part of the New York City transit system from the get-go, its actual building, its planning, whether they were diagnosed or undiagnosed, but from literally sort of the groundwork up. And I'm really interested in the experiences that people have on an everyday basis. So as a social scientist, I essentially study what people say and what people do, and the meanings that they make out of that, and how, tilted up, oops, sorry, awesome. And the ways in which those meanings inform how they interact with others, the kinds of services that they maybe do or do not access, all of those things, how you can do that from direct observation. So I'm gonna talk today kind of 3 things. Kind of a little bit of my background, how did I come to do the work that I do, is the sort of current work that I'm doing related to disability and technology and youth, kind of what am I finding, and then what's sort of like the next sort of steps. And I wanna also pull out within that how that might connect directly to the work that you're doing, in whether you are a parent, there's labor involved in that, or whether you are sort of running programs, all that sort of stuff. And also with that being said, that I'm also interested not just in what the people that I study have to say, but what people and folks like audiences like this do. And so kind of the research process is being kind of this as being a crucial part of that feedback loop for me personally. So excited to talk. Okay. So my background is actually in kids television. I, as a college student at Northwestern, interned in the Education and Research Department at Sesame Workshop. So this is many years before Julia, the autistic Muppet, made her debut. But I've been part of that research process, how that informs script development. Also carry that over to work at Nick Jr., developing some preschool shows there. Currently an advisor on a Ready to Learn, CBS Kids, funded Ready to Learn project, kind of the next generation of PBS Kids shows. But in my initial background entry point into TV, when I started my Ph.D. in 2010, which is when the iPad came out. So it was kind of difficult if you want to study kids, media, to have it sort of stop at the television. You have to keep going in that, especially when TV means also on something like an iPad. I also, as somebody who's really invested in diversity can sometimes be a token word, but thinking about the wide array of individuals who we can label as kids and youth and as families, and the ways in which disability can sometimes get erased in that study, especially when we study kids and families and media. So disability became a really central part in trying to make essentially the study of humans and technology a little more human. Is the way that I kind of like to think about it. So there's two research questions that guide what I do. So what communicative, expressive, and participatory opportunities, so we can talk about what communication means, what expression means, what participation means, what opportunities does assistive, educational, and digital technology, again, those are three related but sometimes can mean different things, technology, make possible for young people with developmental and speech disabilities. So my work has, young people on the autism spectrum have been part of that research, but I'm also interested in other developmental disabilities that can manifest in significant difficulty producing oral speech. So that can mean kids with CP, that can mean kids with a kind of a mix of genetic disorders, but all kind of manifesting in significant difficulty, what we might call talking, and what the role of technology can be in other kinds of expression. So, and then I also am very interested in what social inequalities do new technologies and the institutions that regulate them exacerbate among this population. So I say institutions like healthcare systems, like education systems, what can be exacerbated potentially along intersections of socioeconomic status, ethnicity, gender, and so forth. That to understand what it means to be autistic also means understanding what it is to have a certain class status or a certain socioeconomic status, that all of those identities make up people, and all of those people interact with different institutions. And so I think very holistically, there's a human development theorist, Uri Bronfenbrenner, who talks about sort of an ecological model of human development, and I very much subscribe to thinking about how different kinds of systems shape one another with a kid in the middle. So I've got two books so far that kind of go through this, and I won't be actually talking so much about them right now, but you can look at them. This one is called Digital Youth with Disabilities. It's a sort of white paper book that was funded by the MacArthur Foundation, but it's available as a free PDF online. So have at it on Google, but it basically outlines, outside of thinking about kids with disabilities as patients or as students, what do we know about them as kids who use media and technology like their, like or not like their peers, do? And what is the state of that research? In 2014, that's, things have evolved in different ways, but some frameworks for how to think about that I put forth in that book. My most recent, Digital Youth with Disabilities was published by MIT Press, and also my current book, also published by MIT Press, called Giving Voice, Mobile Communication, Disability, and Inequality. And that book kind of focuses on the adoption of communication technology, again, among young people who one might say have significant, some people might call nonverbal. I prefer to use non-speaking because people can have a love of words even if they aren't able to orally articulate that, and we very often assign sort of verbal with intelligence and with kind of words. But anyway, so I focus on, in the book, 20 families that I did an ethnographic study with to kind of figure out what, specifically nowadays, that these technologies that can support individuals with significant speech impairments aren't just the Stephen Hawking technologies, but are now also just apps on iPads. I don't know how many people here are familiar with the app Proloquo to go. I see some folks. Anyway, so it's a study, it's kind of the most popular app that one might use to kind of talk in that sense. So I studied that because it's often very said that these technologies give voice to the voiceless. And my kind of thought was, well, what does that even mean? You know, that means empowerment, and that might mean, you know, vocalization. But if you study that kind of in the way we think about the ways that technology can be helpful, but also not. And if we assume that it is, then those outcomes don't look the same for everyone. But if we kind of keep reifying those assumptions about the benefits of technology without a critical inquiry into what it looks like in real life, that's what I'm really interested in. So my now more autism-focused work kind of came out of that. Because I feel like I had a lot of people come up to me afterwards, or kind of during the project, and had said something about how the kids that I was studying, because they were not speaking kids, you know, that those kids were, you know, very understudied. And for me, I came through it really the opposite direction, where I was like, well, these are, you know, all kids that use the same technology. I see a real potential for community building across that. I'm very kind of community building focused, and wanted to think about, well, what's the technology experience then of young people across the autism spectrum? So that's where this next project comes from. Kind of what I see kind of as my next book project, tentatively kind of titled Kids Across the Spectrums, Growing Up Autistic in the Digital Age. And I see it as like 3 spectrums at this point. And we can talk also about whether spectrum is a good metaphor or not, because people change in different ways across the lifespan, whether they're sort of fixed at any one point kind of uniformly. But we can think about, you know, different ways that autism manifests in individuals. The socioeconomic spectrum, having access to even the internet as a way to find information, as a way to connect with other people through things like Facebook or blogging. That those are very important things to think about, or access to something like Minecraft. That those are vital things to take into account. And then the media spectrum. So it's the array of media that young people do or do not have access to, that they find themselves drawing on to feel included, or to be happy, to find like pleasure and whatnot. So one way that I started to have been thinking about this is related to what it means to be social in the first place. Because I'm a social scientist and not a clinician, I get to think about these things in somewhat different ways. A sort of grounded theory, it's what it's called in qualitative research. So what do people themselves describe as what it is to be social? How do they act on those meanings? And I was struck by this article that I had found, Prevalence and Correlates of Screen-Based Media Use Among Youths with Autism Spectrum Disorders. I won't read the whole abstract, but what it's measuring is the ways that young people on the spectrum, how they spend their free time, and what they describe as either using social or non-social media. So in this article, what they studied was either use of non-social media, which they characterize as television and video games, or social media, which they describe as, email and internet chatting. That's 2012, so forgive the sort of datedness. But as somebody, again, sort of a grounded idea, I think lots of things are social, even if they aren't Facebook. People have viewing habits, people have rituals around things like video games or television that become social to them in a way that can't be maybe measured in the same way as you might be able to measure rates of emails or chats. But there is social meaning that is derived from it. So it's less a statement about one's being social or not social depending on what media they're using, but what they do with it. So I've been interested in that, and also interested in the ways in which we might think about, from at least an anthropological perspective, social as being something that autistic people can describe in their own ways as being as such. So at UCLA, anthropologist named Eleanor Ox and Olga Sullivan at USC, who's in the occupational therapy department, have wrote about what they have termed autistic sociality. So saying that humans are social, what it means for humans to be social, their definition is that it consists of a range of possibilities for social coordination with others that it's influenced by the dynamics of both individuals and social groups. So that autistic sociality is sort of one possibility for social coordination. If we think about what it is to be social, again, from an anthropological perspective as such. So why is this even important? I would argue that it's important because if we're designing all sorts of new gadgets and technologies, just like any other piece of technology that enters into somebody's existing routines and habits, you gotta know what people are already using stuff for. Because anything, even when the radio got introduced, when television got introduced to folks, it was always like, well, how is this like or not like the radio? How is this like the way I already know how to use this thing? Well, it's hard to understand the implementation, I would argue, of things, robots or Google Glass, remember when that was a thing, for any kind of intervention. We don't actually know what the mediated or technological environment looks like for young people on the spectrum. And again, a sort of wide array of young people, not just who we might think of as the most technologically savvy, which very often becomes code for white upper middle class and male. So wanting to really be able to expand that kind of knowledge base. As I'm kind of running out of time here, but there's 3 questions that are guiding this for me. So what are the media and technology activities, routines, and rituals of autistic children in their informal learning spaces? So at home, on the go, in the community. I'm not so much interested in school, not so much interested in formal therapy settings, but I'm interested in media and technology is in all these places, but what does it look like? In what ways are these practices social, as defined explicitly by autistic youth themselves and by their families? And as like a communication theorist, what are these meanings of what it means to be social? How is this shaped by what we mean by technology or media in the first place in that environment? So I'll just kind of go through, so we're running out of time, so focusing on, kids 3 to 8 right now I'm focused on. Home observations and interviews in the Boston area, a pilot survey that's led by a Ph.D. student at Mass General Hospital in the Autism Language Program at Boston Children's Hospital, as well, sort of this main section of what I'm doing. So some themes, again, this is really early research, so I'm kind of spent more time on the overview than like the findings, but some themes include the sensory environment. Thinking about the ways in which sensory elements become part of family rituals, and the value of media in intimate moments that can be difficult to have. So a mom and a son watching Despicable Me 2 for maybe, if there's 365 days in a year, the 365th time that year. And the role of physical intimacy, though, as part of that ritual. And so sensory inputs as part of how media gets used in family settings. That might also include for this family a pillow that they use, that a mom found out about from they call this the mermaid pillow in that family, the way that mediated experience, because otherwise the kid might dig into mom during that experience, but if there's a pillow there, then it can make something more pleasurable. For another kid, that might mean this mom here has sequins actually on her shirt, so that involves kind of pulling at those sequins a little bit while they're sort of cuddling on the couch together watching TV. So besides and that also might mean bouncing, because this is a very small apartment in Roxbury, Massachusetts. There's no playroom, there's no anything that's like a wide expansive space, so to get like vestibular input, the couch becomes the space to do that. But again, there's some families that I've been spending time with who have a whole room set up with giant things to bounce on. But that that sort of shapes the bodily regulation that a kid might be able to have. Those kinds of distinctions are, again, I think, very important for us to understand any kind of effective treatment. And I'm really interested in places where it might be laborious to go and travel to spend a lot of time in people's homes. You've developed a lot of trust for people to let you in to see things that are messy and not all put together, but it's where everything goes down. So sensory experience is being important. Sibling dynamics, something very understudied, in terms of what it means for again, for a family to talk about what it is to be social, what it means for their kids to spend time together, and how that can look that can be social in direct and indirect ways. That the ways that these two kids are playing with dinosaurs kind of together and separate, with the TV on, there's a big screen TV they're on in the background. The ways in which that, this mom described her autistic son, who's in the front there, as antisocial. And I was sort of interested in why she would call him that, what that looks like, and the ways in which that might, to him, he might have used a different word for himself to call that, but I'm interested in what those observations are and then how that reflects into what choices a parent might make or not make. There's also siblings. This is two siblings who are playing Minecraft on opposite ends of the room. They're super into it. It's funny, they're in opposite ends of the room in the same house, but the youngest one, who's on the spectrum on the left, is playing in his older brother's house in Minecraft. And it's interesting, they shout across the room that they're coordinating play. They also did a sort of Minecraft club at the local Boys and Girls Club. Parents were very, very supportive of this. There weren't sort of limits and rules in ways that parents might be told to do so in general about screen time that would just be silly to apply to this family when it comes to the kinds of pleasure and the kinds of then other skills and other kinds of conversations that if you're able to talk about Minecraft with your brother, what other conversations you might be able to have with other kids at school about Minecraft is a pretty big deal. So the sort of sibling scaffolds is something that's come up. And then one kind of last thing is to talk about home as a sort of alternative social space. So this is young Spencer, he's 4, super into elevators. Sort of another part of the transit system. We talk about from one floor to another, it's transit. Parents were, and he's wearing an elevator button t-shirt, really into elevators. It's elevator video, watching elevator videos on iPad, elevator videos on TV here, sort of projected. But there's no way, parents were super great about taking him to see elevators. There's no way though, sometimes you just can't go see the elevator. That's just not a thing you can do. But you can build a sort of alternative space using media and technology to do so. This is not to say that external, in the community, things aren't also important. But again, thinking about media as a way of making that kind of external space brought home. So that can also, I think, some relevance to the kind of programs that you might be doing and how, sure, you can make a visit to an informal learning space, a museum, a library, but how can that then be taken home and used at home in different ways by different kids? So the next stages of this research involve older kids. So 3 to 13 is kind of the way that I'm bounding childhood here, and I can talk about why I'm doing it that, but certainly you can be 30 or 3 and love Elmo, so that's, there's sort of certain barriers, certain things that I put around there, but oversampling for girls, because just like Amy talked about, there's such a lack of being able to understand autistic girlhood and directly from autistic girls. We have adults talk about their experiences, but the ways in which peer development and friendship and parents making friends with one another, that's all coming through in some of the research that I'm doing. So, and even just among sort of the 7, 8-year-olds, but again, getting a little older. Case studies, wanting to do some more embedded things in after-school programs that are about, whether it's Minecraft clubs or mediated spaces that are either inclusive or directed towards kids on the spectrum, but at the same time wanting to follow those kids home and interview parents and sort of understand the greater ecology of things. And then also just field observations at things at sensory-friendly Sundays at Chuck E. Cheese, or things that are both for free and cost stuff. So I also went to Honk the Musical, a group at Emerson College of students had put together a sort of social story to introduce kids that they were sort of making a sensory inclusive event of this theater musical Honk. So going to these different spaces and kind of finding out how people heard about them, what they enjoyed, what they didn't, and just kind of seeing in what ways, again, people make social out of these spaces. So that's sort of me. That's where the research is at. It's like I said, it's sort of in progress, and these are early findings, but sort of taking taking autistic experiences as valuable and from individuals themselves, and incorporating that into how that might then shape family services and the design of technologies and design of, informal learning spaces and whatnot. Thank you.
So we have some time for questions for our panelists.
Hi. My question is for Ms. Gorenstein, please.
Yes.
Hi. I would like to clarify that I understood one of the things you said. You showed 2 slides from the MRI, one pre-intervention, one post-intervention. Did I understand correctly that post-intervention you could actually see neurological changes and that neuroplasticity is that short to change? And then, did you also say, like 6 months later, you no longer saw it again?
So both of those slides were post. They were of 2 different brain regions. So it was an fMRI study. So we were doing a specific task while children were in the MRI. So you're giving them a task to do while you're imaging their brain. So we did see changes in brain activation post-treatment.
And not then 6 months later? Was it faded?
So it was, the behavioral changes faded. We didn't necessarily scan the children. Not every child scanned post.
Are you concluding from that you have that much plasticity, that you actually can see physiological changes with the correct intervention?
Yes. So I mean, we do. So I'm not saying the social skills curriculum change kids' brains forever, but we do know that interventions do change brain functioning and brain connectivity, which is why the early intervention researchers work, because you know that brains change the most and are the most flexible for all of us when we're younger.
How old were the kids in those pictures?
Those kids were 8 to 12.
It is remarkable.
Yeah, and again, it's not saying brain structure is changing. It's saying during the task, the brain activation, yes.
Okay, thank you.
And again, not every child showed that change. The children who were older and the children who had higher verbal IQs changed the most. So again, our conclusion is not kind of this global conclusion. For this curriculum, the children who were older and who had higher verbal IQs responded better. And we did see kind of both behavioral changes on parent measure forms. We saw some behavioral changes when we did assessments with the children. And what was nice and unique about this study is we were also able to show that it actually had some changes in brain activation.
Sorry, I seem to be the questioner. Actually, it was for Dr. Pletcher. Did I pronounce it right?
Yes, yeah.
On one of your slides, there was a percentage that really stuck out to me, which is that, did I get it right, that 7% more likelihood with siblings and 40% more likelihood with fraternal twins? That just jumped out at me.
Yes.
Why on earth?
Well, it goes to the underlying genetic, contribution to autism, and the fact that, in fact, you do see it, run in families and those sorts of things. And so, again, the idea is that, so in that particular slide, it increases the chances by 7%. As I said, in some studies, it's 1 in 5 siblings end up receiving a diagnosis if one sibling's already. But it's that idea that certainly there's a significant genetic component. Also, one of the best appreciated and well understood risk factors for autism is maternal and paternal age, which goes to, again, that just as we continue to age ourselves, we accumulate mutations that then we pass on to our children. So the longer you live, the longer you wait to have a child, the more mutations you have, the greater chance that one of those variants, one of those changes hit a gene that impacts autism. And so it all fits together in this puzzle that, in fact, that it is things that you pass on that are within families in the genetic contribution that increase the likelihood, increase the chances of that eventual diagnosis.
But am I missing something? That's a huge differential between 7% and 40% between two populations that have the same likelihood of the similar
Yeah.
gene
Well,
and dissimilar, and the only thing that differentiates them is that one set shared a uterus and the other did not.
Yeah, no, and again, the numbers are variable, and that captures one of them. Like I said, sometimes it's a little bit higher, lower, but I think the other part too is it does capture the fact that genetics don't explain everything either. We know that environment has an impact, and that goes to both in utero, but that also goes to just the experience of growing up. And certainly fraternal twins at the same age are going to have similar life experiences versus siblings that are separated by age. So yeah, the slide probably overstates the difference between the two. But again, I think also there is the contributing factor of environment here, where the fraternals share a much greater overlap in environment than your normal siblings do.
Thank you.
I have a question for Meryl. Meryl, I'm wondering if you've seen technology, digital technology used successfully in classrooms, and if that's part of your research. I'm not sure. I know that you've, focused a lot on families.
Yeah, so I have focused less on classrooms. I've been more interested in, when people talk about what goes on at school, like how do they talk about it at home? Do parents, part of these information gaps in really not necessarily knowing what goes on, like in the classroom around technology, or if there is kind of knowledge that maybe it's not being used, or not being used even if it's in a kid's IEP, if it's in the IEP that it should be used. I've spent more time kind of hearing whether something is sort of ultimately going to be beneficial or not. If it's not even used, well then that's a barrier to any kind of technology having a positive impact on like a basic level. And so I'm very interested in those things that, those challenges to whatever successful technology implementation looks like, and the design of the software or the design of the hardware itself. The ways in which not insignificant things like funding for any of these programs, or families who have the ability to move to a much better school district because they've heard that there's lots of resources there, and the families for whom that is not an option. So I'm interested in sort of like this ethnographic approach to understanding, and I do think how that can shape the kinds of services that get designed, or even programs that are around young people in classrooms, developing their own technologies or developing their own, software or whatever. And I think Beth, whether Beth is, we'll talk about that. But I think this larger network approach is needed to, just even before you get to the step of the design of the technology, just that broader impact.
So I'm a professor at Parsons in the New School teaching design, and we have an increasing number of students who come in with documented diagnoses and learning disabilities. And a couple of you touched on helping adults as they transition into adulthood. And there's always this conflict where when they're in college, so much of the accommodation that we give is about not like lowering the requirements, for example, or just not giving more time, and its accommodation is kind of seen as we're not doubling down on them. But then when they graduate, we're still trying to help students integrate into an adult working environment, and there's a little bit of guilt left over from not putting so much pressure in, or not giving really like services to help build those skills while in school. So I guess my very big question is, what can we do on the college level to help students build those skills while they're in school, rather than trying to catch up after they graduate?
Okay. Well, I would just say that I think there's not a lot that we know about that, primarily because when it comes to the funding distribution of like autism research, very little of it goes to stuff like that. So for us to even be able to like fully understand like those implementations, and because so many of them are being underfunded within universities and deprioritized, like our sample set of like evidence isn't super robust to understand those implications from one standpoint. But I will say, from the employment perspective, I think there is a big movement for both teaching young adults on the spectrum the soft skills to be more successful in employment, but I also think there's the reverse in teaching employers how to create environments where individuals on the spectrum can kind of succeed and also show their strengths. So there's like Microsoft, Marriott, Home Depot have created programs because more and more corporations are recognizing that while individuals on the spectrum might have difficulty with executive functioning or some of the challenges that come in the way of probably in college with the extended time or things like that, that if you give them the accommodations, they excel and they often contribute uniquely and give a different perspective. So I think in terms of employers, you will see employers, I think, in the future offering similar accommodations.
Okay, great.
But again, there hasn't been as much research because I think this is a new field, and I think researchers and service providers have been really focusing on children, but children grow up. So there is definitely a need, but I think if you look up, like Microsoft has been like one of the major corporations for this movement in terms of creating programs and accommodating.
And I would say, and hopefully grow up to take leadership positions in those, organizations, because so much of that stuff is like top down. So like it involves like that as part of, again, this like ecosystem.
We have one more question in the back. And as I'm walking back there, I will say our afternoon panel on strengths-based approach to programming will address some of those questions as well.
Hi, I have a question about the genetic research and the genetic diagnosis, I guess, of a more specific diagnosis like the Ph.D. Is that strictly right now research, or is there accessibility for people to sort of get a further understanding?
It isn't just research. These kind of tools and diagnostic techniques are available through physicians, through your primary care physician. And in fact, I think you see more and more of an uptake, and it's becoming more and more part of the routine diagnostic process, because as we gain a better understanding, there is value to be had in that information in thinking about what the next steps are, what the right approaches are. So, and it's a lot of times, it's actually, families and parents sometimes come more informed about these than the physicians themselves do. Right. And more, yeah. Right. So true. And then a lot of times it's the parents coming in and knowing that in fact this is an available tool and asking for the test to be run.
Right.
Because those tools are out there.
We've been to developmental pediatricians and neurologists, and it's never really been offered before, but I've been reading more and more about it. So that's why I ask.
And I will say the American Academy of Pediatrics, it's actually a recommendation at this point for all young children who are getting a diagnosis to get genetic testing. And I will say, I mean, we talk to families every day who get genetic testing, and then the panel does change as there's more gene discovery. So even if there was a negative finding 5-10 years ago, there could be a finding if you did the genetic testing today, just because the panel is changing.
Thanks.
I'd say the first stop is your primary care physician. They can order it. But I mean, your typical diagnostic companies, Quest Diagnostics, they have it. There's Claritas. There's a number of Veritas. There's a number of these kind of diagnostic companies out there that all offer these things, including things like the clinical exome, where essentially you can have every gene in your genome sequenced and analyzed. So these kind of things are orderable.
And like I know the Seaver Center has a clinical genetics department, so families that are not interested in research can go there and get genetics.
And I would say from a technology and privacy perspective, it's important to know the sort of rights around genetic data and how it's stored and who's storing it and who has access to it and used for what purposes.
Well, thank you so much. Join me in thanking our panel. This is really fantastic. Thank you. Thank you guys.